Hello, everyone. Thank you for watching. I'm Paul Pen from Foster Tech. This video, let's prove theorem 1.3 is the basic properties of length of vectors in general in space, Euclidean space. So let V be any vectors in space is a scalar number. It says the length is the first is a positivity. Okay. It says if the length is 0, if and only if V is 0, yeah, of course, right? Okay, but why? So we have to think. The second scalar multiple. Okay, the scalar multiple can factor out, but we have to put the absolute value. Okay, why we need to put the absolute value? Because sometimes C is a negative number. Okay, but length is always be positive. That's why we have to put the absolute value. Let's exactly see why it is true. Let's give a proof. You can set up, okay. Yeah, basically set up. That's V. So let me say V vector is this. So V1, V2 to Vn. Okay, and then look at the A. Did you calculate the length by definition? You know, V vector, the length of a vector is square root of V1 squared, V2 squared, and then goes on to Vn squared, right? Can you see if this equals 0? What do we get? And everyone know, okay, square is non-zero. So if Vi is not 0, and then that should be positive. But now it is 0, so each term has to be 0. This one means each term is 0. Okay, of course, I is from 1 to n. This means V 0 vector. Okay. If and only if means we need to go backwards. Can we go backwards? See, if V is 0 vector, can we go backwards? Yeah, of course. Okay. So each coordinate will be 0. If each coordinate will be 0, the length will be 0. Okay, so that's the first. B. Let's do scalar multiplication. C times V. What is, again, by definition? Okay. So that's C V1, right? The first coordinate will be this, and then squared. C V2 squared goes on to C Vn squared. What do we get? We can factor out the C. Okay, so C squared. But when we factor out the C from the square root, we definitely have absolute value of C. And then what do we have is V1 squared, V2 squared goes on to Vn squared. So there's an absolute value of C times the length of the vector. That's definitely true. Okay, thank you for watching.